Dear students and viewers, in the last three videos, we have been addressing about the atomic number, mass number, valency, and slowly we went into the valency of the first two elements, as well as we found the valency of the groups like sulfates, carbonates, phosphates, etc. Then we slowly migrated why these elements try to form compounds in order to attain the stable octet configuration. So in order that in the last session, we have seen about the ionic bond. Today we have to move into the covalent bond. But before proceeding to covalent bond, we have to discuss some more concepts which are necessary so that you will be able to appreciate and understand the concepts of a covalent bond. So what are the things which are necessary for understanding the covalent bond is that you should know the electronic configuration around the atoms more precisely using the quantum numbers. So today, let us discuss about the quantum numbers, namely the principal quantum numbers, azimuthal quantum numbers. Then we will discuss about magnetic quantum numbers and spin quantum numbers, and how these electrons have been arranged in various shells, subshells, and orbitals. So, as a base of quantum bond, we are going to discuss today about the quantum numbers. The quantum numbers are nothing but, for example, we are now in India. So if I want to address where I have been, then first of all we have to tell whether I'm in which continent. I'm in Asia. Then I'm in India. Then coming to the next point, where I have been. I have been in Tamil Nadu. Then exactly where location. So we want to exactly go to the particular location where you have been. So similarly, only the quantum numbers. So the quantum numbers are used to identify the location of protons or electrons or neutrons. Quantum numbers are used to identify the location of protons or neutrons or electrons. Electrons, because already we know these protons or neutrons have been binded inside the nucleus. So there's no need to check where they are and how they are revolving and what is the property they have, magnetic property. So there's no need to know about the details of the protons and neutrons because they're already in the nucleus. So the quantum numbers are used to quantify where the electrons are placed, in which energy level they have been placed. So that is the main use of the quantum numbers. So just like I told how to move from the top level to the bottom level. Whereas blue. So let us discuss about the principal quantum number. The first quantum number is called as the principal quantum number. There are four quantum numbers. Generally, this first quantum number, principal quantum number, is indicated by a small letter n. Small letter n. The second quantum number is called as secondary or azimuthal. Both are same. Secondary or azimuthal quantum numbers. So it is indicated by a small letter L. It is indicated by a small letter L. Then the third quantum number is the magnetic quantum number. Yeah, I will write the short form. So this have been indicated as M suffix L, magnetic quantum number. Then comes the last one called as the spin quantum number. It is given by as M suffix X. So there are these four quantum numbers are there: principal quantum number, azimuthal or secondary, magnetic, and spin quantum numbers. These quantum numbers are used to identify the location of the electrons more precisely. For example, that's what I told. The principal quantum number is like Asia. The secondary quantum number is similar like to India. If you want to find where I have been, then first is I have to identify the continent. Then I'm converging to what? The country. Then to the state. Then to the particular place. So that is the idea. So just for making some similarity, I'm telling. So let us now see about the principal quantum number designated by the small letter n. All of us know this is the nucleus. Within the nucleus, we know neutrons and protons are there. So this is a solid body. Now the first orbit comes. Now this is called the first energy level. So this is the first orbit indicated by letter K. Okay. Then the second orbits come, or the second energy level, or second shell, whatever the name you can call, it is L. So the third orbit, it is capital M. I am not drawing fully, but you can imagine it's a full circle. Similarly, the fourth one is called as your N. On most of the book, they are given only KLMN, but we can also include further also. It is O, KLMN, OP, like that we can go ahead. So don't stop that there's only KLMN, but still also we can go further. Now, this orbit has more energy, or this particular shell has more energy than M. This L also has more energy than M. So whenever you are coming closer to the nucleus, that orbit has more energy. That orbit has what? More energy. Okay. Let us have a common terminology hereafter. The first orbit hereafter will call us shells. This K will call us K shell, L cell, M cell, and N cell. So hereafter we will not use the term orbit. And within the K orbit, there will be some subcells. Within the L orbit, there will be some subcells. That is called subcells. Let us come afterwards. Now these K, L, M, and N, O, and all called as shells. And here N equal to 1, here N equal to 2, here N equal to 3, and for N means it is N equal to 4, O means N equal to what? 5. It goes on. It goes on. So now where N is called as the principal quantum number. Where N is called as the principal quantum number. Now, what are the maximum number of electrons in the K orbit? K shell. Okay, so the formula is 2n squared. Now N equal to 1. So it is 2 into 1 squared. So the maximum number of electrons in the K shell is 2. This K shell is also called as energy level. This is called as major energy level. So it's called as what? 2 number of electrons can be there in the first shell, named the K shell. When N equal to 2, then it will become what? 2 into 2 squared. So it is 4 into 8. So we can see in the L shell, we can have a maximum of 8 electrons. Okay. And when N equal to 3, it will be 2 into 3 squared. So we can see in the M orbit, M shell, we can have a maximum of 18 electrons. And in case of N, capital N, it is 2 into 4 squared. So 16 into 2 is 32 electrons can be occupied in the N shell. Similarly, O, it is 2 into 5 squared. So 5 squared is 25 into 2 is 50. So we can see the O shell can accommodate a maximum of 50 electrons. More than 50 it cannot accommodate. So until 50 it can accommodate. So these are the energy levels, or the major energy levels, or others called shells, where how the electrons have been distributed. How the electrons have been distributed. Now let us move on to the azimuthal or the secondary quantum number. So secondary quantum number. If I'm going to take this as the nucleus, I will draw a little to the left so we can draw more orbits, more shells. Now, if I'm going to take this K shell, there's only one orbit around this nucleus. So this neutron and protons. Whereas if I'm going to take L shell, it has 2 subcells. This is called as what? K. This is called as what? L shell. But this L shell has 2 subcells. Let us see what are they. If I'm going to take M shell, let us take this the M shell. M shell has 3 subcells totally, including that. Okay, so we can see the major energy level is K, or the shell is K. The major shell is here L, but it has 2 subcells. The major energy level or the shell is M, but it has what? 3 subcells. What about the fourth one then? 4 subcells will be there. For example, if you are going to take N shell, it will have 4 subcells. Very good. Okay, fine. Let us explore what are they. Let us explore what are they. Okay, so we can see here. Here it is called as L. It is called as what? L. So when N starts with 1, 2, 3, 4, L will start from only 0. L will start with what? 0, 1, 2, 3, 4. That is a convention we have made already. So N, the principal quantum number starts with 1, 2, 3, 4, whereas the L starts with 0, 1, 2, 3, 4. What is the 0 is nothing but S subcell. 0 is nothing but what? S subcell. What is this? 1 is called as P subcell. What this 2 is called as D subcell. What is this 3 is called as F subcell. Okay. So when I am going to have K shell, it will have only S subcell. It will have only what? S subcell. When I am going to have L shell, it will have 2 subcells. What are the 2 subcells? S and P. S and P, there are 2 subcells. When I am going to have M shell, it will have how many things? It will have 3 subcells. What are they? It is 0, 1 to 2. 0, 1 and 2. Here it is only 0. Here it is what? 0 and 1. Here it will be called as what? 0, 1 and 2. What is 0? 0 corresponds to S. What is 1 corresponds to P. What is 2 corresponds to D. Okay, then what will be having the N? Capital N shell will have how many layers? 4 layers. So what are the values of our azimuthal quadrant numbers? 0, 1, 2, 3. Okay, 0 stands for S, P, D, F. So we can see, so the M shell, the K shell has only one subshell. The L shell has 2 subcells. The M shell has 3 subcells, and the N shell has 4 subcells. 4 subcells. And the maximum number of electrons in the P is 6. The maximum number of electrons in the P subcell is what? 6. The maximum number of electrons in the S is what? 2. Here also what are the maximum number of electrons in the S? 2. So here we can see it is, if you're going to add both S and P, it will become 8. It will become what? 8. So the number of electrons in the L shell is what? 8. We already also matching. And when I come into SPD, here it is 2, it is 6, it is 10. It is what? 10. So what is the number of electrons? Will be totally 18. So in case of M equal to 3, there is small n equal to 3, it will be what? 2 into 3 squared. So 9 into 2 will be 18. So you can hold a maximum of 18 electrons. Now I told P can hold 6 electrons. I told D can hold 10 electrons. But how? What is the formula? So we can see it is 4L plus 2. The formula is what? 4L plus 2. But here the L starts with 0. L starts with what? 0. So when L equal to 0, what happens? 4 into 0 plus 2. So it will become 2. When L equal to 0 means what is it indicates? S orbit, S subcell. So the S subcell can have a maximum of how many electrons? 2 electrons. Now I will put L equal to 1. So 4 into 1 plus 2. So 4 plus 2 is what? 6. So when L equal to 1, when L equal to 1 is called what? P subshell. So P subshell can hold a maximum of what? 6 electrons. Similarly, you try with the L equal to 3. 4 into 3 plus 2. What is the value? It should be 2. L equal to 2. So 4 into 8, 8 plus 10. 8 plus 2 is 10. So when L equal to 2, it is what? D. So D can have a maximum of what? 10 electrons. So what about next one? L equal to 3. 14. So F subshell can have a maximum of 14 electrons. So like this only, we are able to get what? The number of electrons in the subcells. Number of electrons in the subcell. It's still not, I will not tell the P is away. The P is within the cell only. Which cell? L cell only. This D is also within where? M cell also. This S is also where? Within the M cell only. So that's why I told. Still we are in Asia, but we are in India. Still we are in Asia, but we are in still I can't tell India is outside Asia. So it's going deeper. Okay, like that we are trying to converge. So the formula for calculating the maximum number of electrons in a subcell is given by 4L plus 2. Isn't it? Okay. So I can take 2 as common for both the terms. It will become 2 into 2L plus 1. Isn't it? Now L equal to 0. L equal to 0 means what? 2 into 0 plus 1. So it is 2 into 1 is what? 2. So when L equal to 0 means it indicates what? S subcell. Yes, subcell. And when L equal to 1, it will become what? 2 into 1 plus 1. So it is 2 into 2 plus 1. So it becomes 2 into 3. How many electrons? 6 electrons. So when L equal to 1 means it indicates what? P subcell. When L equal to 3, it will be 2 into what? 2 into 3 plus 1. So 2 into 6 plus 1, 7. So equal to 14. I have missed L equal to 2. So if I am going to put L equal to 2, it will become 2 into 2 into 2 plus 1. So 2 into 5. So 10. L equal to 2 means D. L equal to 3 means F. That is fine. So the formula for deriving the maximum number of electrons, either you can go with the 4L plus 2 or you can go with the 2 times of 2L plus 1. Okay. So let us recollect. When n equal to varies from 1, 2, 3, 4, it is called K, L, M, N, O shells. This is called the principal quantum number. But whereas the secondary quantum number or the asymptotal quantum numbers varies from 0, 1, 2, 3, etc. So when L equal to 0 means it indicates S subshell. When L equal to 1 means it indicates P subshell. When L equal to 2 means it indicates D. And when L equal to 3 means it indicates F. The maximum number of electrons in S is 2. The maximum number of electrons is in P is 6. The maximum number of electrons in D is 10. The maximum number of electrons in F is 14. A K shell have only one S subshell, whereas one L shell will have two subshells. They are nothing but S and P. The M shell will have three subshells. They are nothing but what? SPD. The N shell will have four subshells. What are they? SPDF. SPDF. So this is the way how we have to relate between the principal quantum number and the azimuthal quantum number or the secondary quantum number. Now let us move on to the third quantum number. It's called as magnetic quantum number. It is called as what? Magnetic quantum number. Generally designated as ML. It will be varying between minus L2 plus L including 0. How to find the value of ML? This is the formula. This is the formula to find the value of ML. The formula is minus L2 plus L including 0. Okay. So there is no need to worry about the principal quantum number. It's enough to worry about the secondary quantum number. So the secondary quantum number starts with what? 0, 1, 2, 3. Where 0 is called S, 1 is P, 2 is D, and 3 is F. Okay, fine. Now what you are telling to how to find the ML? When L equal to 0, it is minus 0 to plus 0. But there is nothing called as minus 0 to plus 0, all are 0 only. So there is only one magnetic quantum number. There is only one magnetic quantum number for a S subshell. Now let us come to P. That is L equal to 1. L equal to 1 means it is P subshell. What is the formula for the magnetic quantum number? ML will vary from minus L2 plus L. So it is minus L2 minus 1 to plus 1. So what is in between minus 1 to plus 1? It is 0. So minus 1, 0, plus 1. Okay. So the P subshell will have 3 orbitals. This is called what? Orbitals. So I will recall once again. The naming with the principal quantum number is called as the shells. Okay. Or the major energy levels. Okay. It's called as what? Major energy levels. It is associated with what? Principal quantum number. The subshells are associated with which quantum number? Azimuthal quantum number or secondary quantum number. Okay. So it is called as sub-energy levels. Subshells are what? Sub-energy levels. The subshells are made up of what? Number of orbitals. Number of what? Orbitals. That's what I'm saying. We keep on going deeper. So when L equal to 0, the ML is also what? 0 only. So there's only one orbital. There's only one orbital. Whereas when we are going for L equal to 1, which means the formula for magnetic quantum number will vary from minus 1 to plus minus L to plus L, which means here minus 1 to plus 1. So it's minus 1, 0, 1. So there are 3 orbitals. For P, we have 3 orbitals. For P subshell, we have 3 orbitals. Now let us try to explore for L equal to 2. What is L equal to? D subshell. L equal to is what? D subshell. So what is the formula? Minus L2 plus L. So it's minus 2 to plus 2. So what are the things will come between minus 2 to plus 2? Very good. Minus 2, minus 1, 0, plus 1, plus 2. So how many orbitals are there? 5. So there are for D orbitals, for D subshell it have 5 orbitals. So similarly, what happened when L equal to 3? L equal to 3 means F subshell. 7. Very good. So how minus 3 to plus 3? I don't want to bore you. So minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Very good. How you tell me? Yeah, that's also fine. So the another formula, very good. Then the another formula to find the magnetic quantum number is 2L plus 1. Very good. I'll go with that. So this way also we can find out. The formula is minus L2 plus L including 0. The other way what you told is also right. It is 2L plus 1, isn't it? When L equal to 0, which means what? S subshell. Okay, so what will happen? It will become 2 into 0 plus 1. So there's only one magnetic, there is one orbital. So called as what? One orbital. And when L equal to what? 1. So it become what? 2 into 1 plus 1. So how many things are there? It is 2 plus 1 is 3. This 3 only I have told us minus 1, 0 plus 1. Both the same. But how many magnetic quantum numbers are there? 3. How many orbitals are there? 3 orbitals are there. Very good. So this formula also we can use. That formula also we can use. Anyhow, you have to understand that when L varies, the magnetic quantum numbers also vary. The number of orbitals also increases from 1, 3, 5, then 7. Then so like this. This is S. S subshell will have 1 orbital. P subshell will have 3 orbital. And phi subshell will have, D subshell will have 5 orbital. F subshell will have 7 orbitals. This orbitals indicates magnetic quantum number. This orbitals indicates what? Magnetic quantum number. Then what is meant by S? Every orbital can hold 2 electrons. Every orbital can hold what? 2 electrons. 1 electron rotating anti-clockwise. In books they will give it moves upwards. It moves what? Upwards. But when you are going to see the rotation, it will be what? Anti-clockwise. The other electron will be clockwise. It will be what? Clockwise. So totally it will try to they become neutral. It will try to become neutral. So this is the way every orbital, this is what? S orbital will have 2 electrons. Now P has how many orbitals? 3 orbitals. So it is P has 3 orbitals. So what are they? It is Px, Py and Pz. So this every orbital can hold how many electrons? 2 electrons. One in this direction, one in this direction. One in this direction, one in this direction, one in this direction, one in this direction. This rotation of the electrons, either clockwise or anti-clockwise, indicates the spin quantum number. So every orbital can hold how many electrons? 2 electrons. That is given by spin quantum number. That is the fourth quantum number. So I am not separately writing the heading, but it's understood. So it is p orbital. What is a d orbital? Has 5 orbitals. D subshell has 5 orbitals. So what is the maximum number of electrons?
One each shell has 2 electrons.
At one each orbital will have 2 electrons. So 5 into 2 will be 10 electrons. But I have to tell you, if there are 7 electrons, first these 2 electrons will not be filled up. So first all the electrons should have to fill up in the same direction, same rotation. So you all will be taking the upward direction. Now only the other thing will happen. That is what? Now only it will try to occupy like this. So if you have 7 electrons, it will occupy like this only. If there are only 3 electrons, then how you have to fill up? In the d orbital. First 3 only, in the same direction. In the same direction. So now you can understand what is meant by quantum number. The quantum numbers are used to identify where the electrons are there in an element, where the electrons are placed in an atom of an element. Okay. Now let us tell what is the meaning of 3D7. So what is, first of all, this indicates? What does 3D7 indicates?
3 orbitals.
What does 3D7 indicates?
7 electrons are there.
What does 3D7? It indicates the location of an electron. It indicates the
Location of
where it is located. That only it is given by this address. Where I have been? I have been in Asia, I have been in India, I have been in Tamil Nadu. So that address only is given by this one. So it is the location of a single electron only. Location of a single electron. So now you tell me. Now whatever you told is right. Now what you told? What is 3? What is 3 here indicates?
shell.
A shell. Very good. So this shell. Shell means what? N equal to 1, 2, 3. Because n starts with 1, 2, 3. So it's K, L, M shell. It is what? M shell. Okay. So M shell, how many electrons can be there? 18 electrons can be there. What is the formula? 2 into 3 squared, 2n squared. So 18 electrons can be there. Out of this 18 electron, where is there? This. Yeah. Now we are coming. It is in the D cell. So what is D cell? Because when n equal to 3, what about L? L can be 0, 1, 2. Now the D indicates what? L equal to 2. L equal to what? 2. Okay. So it is the D orbital. It's it's in the D subshell. It is in the D subshell. D subshell can have how many orbitals? Yeah. D equal to what? Now S P D. So D equal to 2. So how many orbitals it can have? Minus 2 to plus minus L to plus L. So minus 2 to plus 2, including 0. So minus 2, minus 0, minus 1, 0, plus 1, plus 2. So there are 5 orbitals. There are 5 orbitals. 1, 2, 3, 4, 5. Now, where the electron is there? 1, 2, 3, 4, 5. Isn't it? Now it's 7th. So it is 6 is here, 7 is here. So now this value indicates about this electron. Whatever I indicated in the red color, this electron has been located by the value what? 37. Got the logic? Okay, so it's very simple. If I'm going to take a 2s2, what does it indicate?
Second electron.
Yeah, n equal to 2. N equal to means L shell. Okay, then what about a small l? Yes, yes means small l equal to 0. Small l equal to what? 0. And what about 2? So it's a l equal to 0 means there is only one orbital because minus 1, minus L to plus L, minus 0 to 0 plus 0. Okay, so it is only one orbital. One orbital means how many electrons are there? 2 electrons. So one is in the positive upper direction, in the negative direction. Now we are able to tell about this electron. So now what is the use of the quantum numbers?
Find the location.
To identify the location of the electrons. Moreover, we'll get the energy levels, we'll get the properties, all those things we'll get. The main thing is just like the address, how we are going to enriching the particular. Here d equal to, no, d equal to 2. L equal, okay, L equal to 2 corresponds to d. Yeah, very good. So you are right. L equal to 2 corresponds to d cell, which will correspond to 5 orbitals. Which corresponds to 5 orbitals. Very good, very good. Now, there's a principle called as Aufbau principle. There's a principle called as what? Aufbau. It will be quite interesting. Aufbau. This principle is also called as building up of electrons. Building up of electrons. How we are to tell means the building of electrons will take place in this order. First is 1s, second is 2s, 2p, the third is 3s, 3p, 3d, the fourth is 4s, 4p, 4d, 4f, the fifth is 5s, 5p, 5d, 5f, then you can add a 5e. Okay, now the thing is how we have to fill means we have to go like this. 2. You please put the direction also. This my arrowhead is important. This one. Okay. Now what are the results we got? It is that 1s2. Why I put s2? Because s can hold a maximum of 2 electrons. 2s2. After completing 1s2, I had to complete what? 2s2. Then I had to go. You should not go to 3s. I had to go to this side. So it will come like this. If you want, I can. Got it? Here also it came like this. So 1s2, 2s2. For after 2s2, it has to come from that direction. So it will be 2p what? Because p can have a maximum of 6 electrons. P can have a maximum of 6 electrons. Then you are coming here. Then it will go to where? 2s, then it will come to 3s. So it is 3s2. Then after 3s, 3p, 6. Yeah, very good. Then 4s2, you see. After 3p6, it comes to 4s2. After 4s2, yeah, you see 3d is getting filled after only 4s. Okay, so it is a 3, 10. What does it indicate means the electrons will be filled according to the increasing energy levels, which means 3d has more energy than 4s. 3d has more energy than 4s. So that only we can see the 4s is getting first filled up, then only is coming to what? 3d. So we are always building up the electrons in the increasing energy levels. Okay, so which means the 4s orbital has lesser energy compared to what? 3d. After 3d, what is coming now? 4p. 4p, 6. Then 5s2. So it goes on. It will be coming to what? 4d. Okay. Or if there are some more things, it will come there. If you have 4f, first you will come with the 4f, then like this will come. Okay. So now this type of arrangement of electrons in the increasing energy level is called as Aufbau principle or building up of electrons. Building up of electrons. This is most required when you want to find the valency. In the earlier classes, what we discussed with respect to the valency is a generic idea. I will not tell this wrong, but it's not the complete idea. But that is not the complete reason. Now what we are going to find out the valency is more accurate. Okay. Now let us, this value can be there. I will take now potassium. What is the atomic number of potassium, Karna? 19, very good. It is 19. So how this 19 will be there means 2, 4, 10, 12, 18 and 1, 19. So we have to write like this. 1s2, 2s2, 2p6, 3s2, okay, 3p6. If you're not able to write like this, once again you draw the diagram. Nothing wrong. It will take some 2 more minutes, but you have to write carefully. So 4s1. So this is how the electrons have been arranged. How to write these things actually means the first orbit is 1s2, 2s2, 2p6. Actually, I should not write like this. First, I have to fill it with one direction, then I have to fill in the other direction. Then this is what? 3s2. Then 3p6. I am telling like this. First, we have to fill up in only one direction. Then only we have to fill up in the other direction. Now 4s1. So if you want, you can write also 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Now I can redefine the valency. The redefined valency is nothing but the number of unpaired electrons in the outermost subshell. The outermost what? Subshell. Here the outermost subshell is what? 4s. And it has only one unpaired electron. So the valence of potassium is what? 1. So this is the actual meaning. But how we discussed earlier when I was teaching to you earlier, first it is 2, then it is 8. So it is 18, 10 is over. So the remaining is 9. So in order to become octet, I told it has to give away one electron. It's also okay, but not more accurate. But this is more accurate. Here we are going deeper. Now that's what I told. I am redefining the term called as valency. The valency is defined as the number of unpaired electrons in the outermost subshell of an atom is known as valency. So the unpaired valency is 1 here. So this is the most accurate form. This is not a this is more 100% accurate. Okay. Now, Kana, can you tell me what is for a atomic number of let us take aluminum. Let us take what? Aluminum. What is the atomic number? 13. So what is 1s2, 2s2, 2p6, 3s, 3s2, then 3p1. So how many unpaired electrons is there?
Almost.
No. You listen here.
Only one.
1s2 is 2, 2s2 is what? 2, 2p6 is what? px, py, pz. I have to fill up like this, then in the opposite direction. Okay, then 3s2. Then, it is 3p. So it is 1s2, 2s2, 2p6, 3s2, then 3p6 it can be, but we have only one electron. So from this, what is the valence of aluminum? But whether is right? Valence of aluminum is 3. Valence of aluminum is what? 3. How we told earlier? Atom was 13. So 2, 8, 3. So the number of electrons is what? 3. We told it is 3. But when I am writing like this, I am getting a valence of only 1. Whether this is right or this is right? This is right. This should be right. But actually this is right. This should be right. But this is what? Actually coming right. Okay. But I told it's not more accurate. This is more accurate. So how? Can you imagine? Can you recall? You'll get the answer. Thus I want to rethink. The valence should be 3. But we are having the valence is what? Only 1. How to make it 3? Now here, what is the outermost shell? Outermost, I not a subshell. What is the outermost shell?
Now it is M.
M, that is 3. That is M is what? 3. So this is the outermost shell. 3. This is, if you want, I can tell. This KL M. Okay. Now this is 3 means. Now what happens means both are in the same shell. Both are in the same shell. Now whenever it's trying to form a bond with other element, now one of the electrons will jump from 3s orbital and move to 3p orbital. Now one of the electrons will jump from what? 3s orbital. It will become 3s1. Yeah. It will move from, very good. It will move from 3s to one of the electron will be transferred from 3s to 3p. Now my question is whether 3p has more energy than 3s or not. Whether 3p orbital has lesser energy or more energy than 3s orbital. 3p?
Has lesser energy than
3s will have lesser energy than 3p. You can see here, 3s is having lesser energy than 3p.
Okay.
Because we have written the Abba principle. So the lower energy level gets filled up first,
Yes, sir.
then the higher energy level. So which has more energy? 3p only.
Yes, sir.
So when you want to transfer an electron from 3s to 3p, whether you have to supply energy or what? Yes, we have to supply energy. Then only one of the electron will be moving from this to this one. Actually, what we have written earlier as 3s2 and 3p1 is called as ground state electronic configuration. It's called as what? Ground state. If you want, I will write it once again because the first time you will be hearing to the lecture. So this is not there. So this type of electronic configuration is called as ground state electronic configuration. But what will happen means whenever it's going to form some bond with the chlorine or something, it will take some energy and one of the electron from s orbital will be pumped or will be transferred to 3py. 3py. Definitely it requires energy because there's lower energy. Now we want to go to what? Higher energy level, so it absorbs energy. So now what will happen means 3s2 will become 3s1, whereas 3p1 will become what? 3p2. Now how many unpaired electrons are there? 3 unpaired electrons are there, and hence the valency of aluminum is what? 3. Okay. Now my question is, I'll come to this. That is what we are going deeper. That's what I told you. The class will be interesting, but you should be going deeper. Huh? Okay. Yeah. This one. 3s1 and 3p2. Now aluminum has a valency of 3 now. It's going to combine with chlorine. Let us say there are 3 bonds. Let us say what is valency? Is a bond. Is a bond. So there's a bond within, because aluminum has valency of 3, chlorine has valency of 1. So when I'm going to cross multiply, it will become what? Al1 Cl3. So one is not required. So AlCl3. Now there are 3 bonds for aluminum and 1 bond for chlorine. So the valency of aluminum is what? 3. Because there are 3 lines, 3 bonds. The valency of chlorine is 1 because there is only 1 bond. Now my question is, can I ask the question? Whether this bond of this aluminum and chlorine will be same for all 3 bonds or it will be different.
It is same, sir, but not 90 degrees.
No, I'm not asking about the angle. That is the angle between these bonds will come because of the repulsive force between the bonds. Because of the electrons. Because they are, that will discuss when you are discussing covalent bond. Now my question is, whether the bond strength of this aluminum, let us say this chlorine 1, this chlorine atom 2, chlorine atom 3. Now aluminum is common. Aluminum with chlorine 1, aluminum with chlorine 2, aluminum with chlorine atom 3, whether all this bond will have same strength or different strength. Why?
So it is connected to S.
One of the bond is connected to s orbital and other 2 bonds are connected to what? P orbital. So this P orbital has more energy. So 2 bonds will be stronger and 1 bond will be lighter. If you write like this, they will give 0 marks. Now what is the answer? All the 3 bonds are having equal energy. All the 3 bonds are, what you told is right. Actually, I also thought like you. So the aluminum chlorine bond, this first bond, if it's going to interact with the S electron, then I thought this bond will be having lesser bond strength. Whereas the other 2 things have p orbital electrons, isn't it? So they have more more strength. So I thought one of the aluminum chlorine bond will be lesser in strength, and other 2 bonds will be more, and they'll be equal. Like they thought. But in the book they have given all the 3 bonds are of equal strength. Then what is the reason? You know the reason. You told me the reason. Hybridization. Now this s electron will not be alone. This p electron will not be alone. Now yes, you take a box. You put one s electron. You put both p electrons. One is px, other is py. You shake it well. Now you make 3 electrons. All these 3 electrons are called as sp2 electrons. sp2 hybridization. So I will have 3 electrons of equal strength. I will have 3 electrons of what? Equal strength. Okay. So these 3 bonds are equally have. This is really good. So there's nothing to feel discussed. Okay. So this This type of hybridization is called as what? sp2 hybridization. Before they're undergoing the bonding, they'll try to become what? Equal strength. That hybridization is called as what? sp2 hybridization. This concept I can't explain when I am teaching what? The earlier of the generic terms. That on the day I want to just explain what is the valency of aluminum. But now we are going more interested because the concept is somewhat complex, but it's interesting. But it's what? This is the actual way of finding the valency. So today we came to know what is principal quantum number, what is secondary or simple quantum number. From that we tried to find what is the magnetic quantum number. From that we came to spin quantum number. After these things we tried to find the valency once again. Earlier also we know how to find the valency, but that's a crude method, not most accurate. But today when we are trying to find the valency, we redefine the valency as the number of unpaired electrons in the outermost subshell. There we came to know that aluminum will have only one valency, but actually 3. Then we tried how it will be, because one of the electrons jumped or promoted from 3s orbital to 3p orbital. So my question came, whether when it's going to bond with the subchlorine atom, whether this bond will be of equal strength or not. Initially, I also thought like you, it will be one bond will be weaker, other 2 bonds will be strong. It's not like that, it's equal strength. Then what is the chemistry they involved? So they also did research like us only. Then they studied why it is of equal strength. Then they tried to find these 3 things have combined together to form sp2 hybridized orbitals. These orbitals electrons will react with the chlorine atom to form the covalent bond. So I hope it is quite interesting. I hope I will stop the lecture for today's section here. In the next section, based on this valency, how to find the valency and Aufbau principle, the next section we will discuss with Hund's rule, Pauli exclusion principle. Then we'll go to covalent bond. You will enjoy. All this chemistry what you're studying is called as which chemistry? Physical chemistry. Because we are trying to see how the electronic convections are there. Okay. As well as it can be called as inorganic chemistry also, because not dealing with carbon compound, but generally is physical. But generally is called as what? Physical chemistry. So we'll stop here.